we're in a lot of trouble. The United States uses about this much power per year. On the other hand, Japan uses less than half of what we do. But here's where we're in trouble. India and China, that make up 40% of the world, they haven't fully industrialized yet. And yet when they emerge, where's the power going to come from to support them? They predict that we're going to need, in the next 15 years, 70% more power. Think about it. Every nuclear plant, every coal plant, every hydroelectric dam, we almost need to double. Where's that power going to come from? Does anybody really think this is the answer? Everybody's always talked about solar and how solar can be our savior. The problem is solar's too expensive. Until now. We are Energaia. We have figured out how to make solar technology cost effective. Now, what are solar technologies? Well, you have silicon wafers, and silicon wafers can put out a lot of power, but they're expensive. Counter to that, you have plastic sheets with thin films on it. The problem with these plastic sheets is they're dirt cheap. However, the performance is really low. So how do you fix that? Well, the thing is, on these plastic sheets, you have very small areas that have performance levels on the level of a silicon wafer. And so what we figured out is how to take that small area and make it uniform across the entire sheet. And what is our secret? It's our tool, Solargy. It's about the size of a phone booth. And our secret is that we use multi-mode acoustic waves. We use different mode acoustic waves in order to get all the atoms to go out to the edges. And not only that, but also to make it deposit faster by taking away the depleted atoms and then use a different mode to inject new fresh atoms for deposition. And the venture capitalists agree. This is probably the best chance we have in order to make solar viable. Ultimately, solar has to be a manufacturing process. This is what a typical solar line looks like right now. And these are the material deposition systems. Now, the issue with these systems is they're honking big. And being big, they consume a lot of power, take a lot of floor space. Also, they're vacuum driven, which means they have a lot of downtime. You can replace all of that with this many Solargies. And to give an idea of how compact this system is, that's the size of a human being. That's the efficiency that we offer. Not only that, but by doing this, we lower costs, and we become less than half of First Solar. They can't drop price on us unless they want to go bankrupt. And so we carve out and leapfrog the competition. Now, how are we going to make money? Well, we're just not going to jump into solar systems. We're going to evolve. And first, we're going to sell PV cells. A lot of applications that need solar cells, even toys. After that, then we'll start building modules. And from modules, we could start selling systems. Now, what markets are we going after? Well, we're not going to go on full energy systems right away, because then that goes into First Solar and the Chinese solar makers and everything else. No, we're going to find a nice niche market where we can make money and get us going. And one big area where we can get into are carports. Electric cars are exploding, and there's not enough places where you can plug in. So what we want to do is make modular carports that can go into any parking lot and start charging your car up. Train cars is a market people don't think about. What we thought about was that solar takes up a lot of area. That's the only negative of it. So we thought about transportation that has a lot of area. Train cars. And the sister to train car is going to be trucking. So is this approach really economically viable? Well, when you look at a train car, it's going to cost about $90,000 because they need 30 kilowatts. However, these are capital investments. In a capital investment, you want your payback to take place within 7 years. But the payback period is heavily dependent on how much the cost of gasoline is. Well, even if gasoline drops down to $2.10 a gallon, you'll get your payback in 6 years. And then after that, it becomes pure profit for them. If gasoline gets up to $5.50 a gallon, which isn't really all that ridiculous, but also in Europe right now, gasoline is on the level of $6 or $7. You get your payback within 2 years. So this becomes a very attractive proposition for the train companies. Who's going to pull this off? Who are the people that need to make this happen? Our core team is myself, who has a lot of patents. I'm the one who created this technology and multimode electrodeposition. And my partner, Tony Mafia. Now, this is a manufacturing technology. So what you're fundamentally saying that this is about factories, and Tony has opened factories all along the Pacific Rim. He understands the cost, he understands the building and everything else. But most of all, we're both MBAs. We're not science project people. We want to make a profit, we want to make a business, and we have the mindset for it. Now, financially, how are we going to do? Well, the first year, we're going to be building tools, and we're going to be doing testing and qualifying and things like that. So we're not going to be bringing in any money. But by the second fiscal year, we can use these tools and start selling product, get our name out there, start building a brand. And then by the third year, we'll reach break even. And when we reach break even, what we're going to do is go public. And by going public, now we can go build our mega factory. And so the rate of return on this, as you could see, is considerable. This is how much money we need. Basically, we need money to cover us for the first 2 years when we're not making money. And by the third year, we'll be self-sufficient. And so what we're asking for is $2 million for a 35% equity stake in our company. Thank you.